Assalamu alaikum. Welcome to lecture number 27 of the course on statistics and probability. Students, you will recall that in the last lecture we discussed in detail the concept of bivariate probability distributions, both discrete and continuous. Towards the end of the last lecture, we began the discussion of two important properties of mathematical expectation that are valid in the case of bivariate distributions. Expected value of x plus y is equal to expected value of x plus the expected value of y, and the other property that if x and y are independent, then expected value of xy is equal to expected value of x into expected value of y. In today's lecture, I will begin with a detailed discussion of exactly these two properties with reference to the same example that we were talking about last time. As you now see on the screen, if we have a situation where x and y are two discrete random variables with the joint probability distribution given as you see on the slide, and if we are required to find expected value of x, expected value of y, expected value of x plus y and expected value of xy, then in order to find E of x and E of y, we will compute the marginal probability distributions G of x and H of y. As indicated in the last lecture, G of x will be found by summing the joint probabilities over y, and H of y is found by summing the joint probabilities over x. So, as you now see on the screen, in this example, the probabilities which are denoted by G of x are 0.40 and 0.60. On the other hand, the marginal probabilities of y are 0.25, 0.50 and 0.25. Students, in order to compute expected value of x, our formula is sigma x into G of x, and applying this formula we obtain 0.80, which is the product of 2 and 0.40, plus 2.40, which is the product of 4 and 0.60. So, the expected value of x comes out to be 3.2. In a similar manner, we will find the expected value of y given by sigma y into h of y, यानी y values को h of y की corresponding values से multiply कीजिए और इन products का sum ले लीजिए, and doing so we obtain expected value of y equal to 3.0. Hence, as you see on the screen, expected value of x plus expected value of y comes out to be equal to 6.2. Students, what we are interested in now is to compute the expected value of x plus y. और जैसा कि मैंने आपको लास्ट टाइम बताया था, इसका फॉर्मूला थोड़ा सा complicated तो नहीं कहना चाहिए. It is an extension, a kind of an extension of the formula that you have in the univariate situation. So, the expected value of x plus y is given by double summation xi plus yj into f of xi yj. And what will we do in order to solve this expression? देखिए, इस प्रॉब्लम में हमारे पास 6 सेल्स हैं इन द बॉडी ऑफ द टेबल, और हम ये करेंगे कि हर सेल में हम कॉरेस्पॉन्डिंग x वैल्यू और कॉरेस्पॉन्डिंग y वैल्यू को ऐड करके उसी सेल के टॉप कॉर्नर पे लिख लेते हैं. So, as you now see on the screen, the first sum of this type will be 2 plus 1 because the first value of x is 2 and the first value of y is 1. And this sum 2 plus 1 is written in the top corner of the first cell. Similarly, we write 2 plus 3, that is 5, 2 plus 5, that is 7, 4 plus 1, 4 plus 3 and 4 plus 5 in the top corners of the other cells. In other words, students, all we have to do is this. जो भी सेल आप कंसिडर कर रहे हैं उसके अगेंस्ट जो y वैल्यू आपको टॉप पे मिल रही है और उसके अगेंस्ट लेफ्ट साइड पे जो x वैल्यू आपको मिल रही है, आप उन्हीं दो x और y वैल्यूज को ऐड करके उसी सेल के टॉप कॉर्नर में लिख दीजिए. सो इट्स एक्चुअली वेरी सिंपल. एंड द नेक्स्ट थिंग इज टू मल्टीप्लाई दिस सम दैट यू हैव रिटन with the probability of that you have in that particular cell, and thus you will have the product of xi plus yj and f of xi yj for any cell ij. Of course, ij is the general expression. I means we are talking about the ith row and j means that we are talking about the jth column. And so combining the two, we can say that we are talking about the ijth cell. I की वैल्यू 1, 2, 3, 4, j की वैल्यू 1, 2, 3, 4, इस तरह से आप उस तमाम तर टेबल जो है उसको आप हैंडल कर सकते हैं. All right. Now that we have all these sums multiplied by their corresponding probabilities, students, all we have to do is to add these in order to get expected value of x plus y. So, as you now see on the screen, we obtain 0.30 plus 1.00 plus 0.70 plus 0.75 plus 2.10 plus 1.35 and the sum comes out to be 6.20, exactly the same that we had when we added e of x to e of y. दूसरी प्रॉपर्टी जो मैंने आपके साथ डिस्कस की वो ये है कि if x and y are independent, then expected value of xy is equal to expected value of x into expected value of y. तो इस प्रॉब्लम में ये देखने के लिए कि क्या x और y वाकई इंडिपेंडेंट हैं, we will have to try to see whether or not this equation holds. And if I look at the right hand side of this equation, e of x into e of y, 3.0 into 3.2, obviously I obtain 9.6. लेकिन सवाल ये पैदा होता है कि जो लेफ्ट हैंड साइड है e of xy, is that also equal to 9.6? So, what do we do? Students, the procedure is very similar to the one that I just explained. As you now see on the screen, the expected value of xy is given by double summation xi yj into f of xi yj. So, this means that in this particular situation, we do not have to write the sum of the x value and the y value in the top corner of any cell. Rather, we write the product. Therefore, the value that we write in the top corner of the first cell is 2 into 1, and that is 2. For the second one, we write 2 into 3, and that is 6. Next, 2 into 5, which is 10, and so on and so forth. Multiplying each one of these products by the corresponding probability, we obtain all those products whose sum is going to give us the expected value of xy. And students, when you work on it exactly the same way as I explained a short while ago for the sum, you find that the expected value of x into y also comes out to be 9.6. Hence, we can say that in this particular example, the two random variables x and y are indeed statistically independent. Students, this was the computation of the expected value of x plus y and expected value of xy in the discrete situation. Let us now consider the continuous situation, and I hope you remember that in the continuous situation, the summation sign is replaced by integration. Let us do this with the help of the example that you now see on the screen. Let x and y be independent random variables with joint probability density function. F of xy is equal to x into 1 plus 3y square divided by 4, and this expression is valid for x lying between 0 and 2 and y lying between 0 and 1. We would like to compute the expected value of x, expected value of y, and to verify the two properties that we have already discussed. In order to find the expected value of x, we will first of all compute the marginal distribution of x, and as explained last time, for this purpose we will find the integral of our expression with respect to y, and doing so g of x comes out to be x over 2. Similarly, to find the marginal distribution of y, we integrate our expression with respect to x, and doing that the marginal distribution of y comes out to be 1 plus 3y square divided by 2. Now, in order to find the expected value of x, the formula is integral of x into g of x with respect to x. Students, ये जो मैंने आपके साथ अभी फॉर्मूला शेयर किया, मैं आपको इनकरेज करूंगी कि आप इसकी जो सिमिलैरिटी है विद द फॉर्मूला ऑफ द डिस्क्रीट सिचुएशन उस पर गौर कीजिए. इन द डिस्क्रीट केस वी हैड expected value of x is equal to sigma x into g of x, और अब हमारे पास क्या है, integral of x into g of x, and of course the integral is with respect to x. तो बहुत सिमिलर फॉर्मूला है और कोई ऐसी चीज नहीं है कि जिस पे आप कंफ्यूज हो. So, as you now see on the slide, the expected value of x in this particular example is the integral from 0 to 2 with respect to x of the expression x into x over 2, that is x square over 2, and applying this integral and applying the limits 0 to 2, our answer comes out to be 4 by 3 or 1.33. Similarly, the expected value of y is given by the integral of y into h of y, the integration being with respect to y, and applying this formula, e of y comes out to be 5 over 8. Now, the more complicated part of the example, and that is to compute the expected value of x plus y. अब फिर वही पहले वाली बात कि जो डिस्क्रीट केस में हमारा जो पैटर्न था उसी को फॉलो करेंगे इन द कंटिन्यूअस सिचुएशन. इन द डिस्क्रीट केस वी हैड डबल समेशन एक्स आई प्लस वाई जे इंटू एफ ऑफ एक्स आई वाई जे, और अब instead of double summation we have double integral. So, as you see on the screen, expected value of x plus y is the double integral of x plus y into f of xy. And applying this in this particular example and going through all the steps in a fashion similar to what I explained in the last lecture, the expected value of x plus y comes out to be 47 divided by 24. Also, we are interested in the expected value of xy, and very similar to what we have just done for x plus y. In this case, we have the formula double integral of xy into f of xy. And once again, applying the method that is already known to us, the expected value of xy in this example comes out to be 5/6. Hence, students, we find that both the properties are being fulfilled. 4/3 plus 5/8 is equal to 47/24, and 4/3 multiplied by 5/8 does come out to be equal to 5/6. Hence, e of x plus e of y is equal to e of x plus y, and because x and y in this example are independent, therefore, e of x into e of y has come out to be equal to e of xy. All right. The next concept that I am going to discuss with you students is the covariance and the correlation of bivariate probability distributions. आपको याद होगा कि हमने correlation का concept पहले भी discuss किया था. In lecture number 15, immediately before we started the segment on probability theory, we had a lecture on regression and correlation. और आपको याद होगा कि वहाँ पे we were dealing with sample data. यानी हम पूरी population से तो data collect नहीं किया था ना. We had a sample and we had measurements on two variables, for example, height and weight, or marks in mathematics versus marks in statistics, यानी दो related variables. तो अब हम इस वक्त वही मौजू दोबारा डिस्कस करने लगे हैं, but the difference is that now we are going to talk about the covariance and the correlation of not just a sample but an entire probability distribution. Students, यहाँ पे एक interesting और important point आप note कीजिए. देखिए, जब हम कहते हैं ना कि we are dealing with a probability distribution, तो दूसरे लफ्जों में आप ये भी कह सकते हैं कि we are dealing with the entire population. और पूरी population जो होती है, उसी में से आप एक sample draw करते हैं ना. तो sample अगर draw करके आप वो सारी बातें करें, तो then we say that we are talking about descriptive statistics. इसलिए कि वो एक sample draw किया और उसी को describe कर रहे हैं. लेकिन जब आप इस concept को expand करते हैं to the entire population, then we are talking about probability distributions, क्योंकि हर population की एक distribution होती है. All right, what is the basic concept of covariance? Students, as you now see on the screen, the covariance of two random variables, x and y, is a numerical measure of the extent to which their values tend to increase or decrease together. It is denoted by sigma xy, and it is defined as the expected value of x minus e of x multiplied by y minus e of y. The shortcut formula is covariance of xy is equal to E of xy minus E of x into E of y. Students, आपको याद है ना कि जो हमने वेरिएंस डिस्कस किया था इन केस ऑफ प्रोबेबिलिटी डिस्ट्रीब्यूशन, उसका शॉर्टकट फॉर्मूला क्या था? द एक्सपेक्टेड वैल्यू ऑफ एक्स स्क्वायर माइनस द एक्सपेक्टेड वैल्यू ऑफ एक्स होल स्क्वायर गिव्स यू द वेरिएंस ऑफ द रैंडम वेरिएबल एक्स. तो आप देखिए कि उसमें और इसमें कितनी सिमिलैरिटी है. जो मैंने वेरिएंस के लिए भी कहा, अगर मैं उसको इस तरह से कहूं that the variance of x is equal to the expected value of x into x minus the expected value of x into the expected value of x, और उसके बाद आप जो सेकंड x मैं कह रही हूं उसकी जगह पर y रख दें तो आपको क्या मिलेगा? expected value of x into y minus expected value of x into expected value of y. Exactly the same shortcut formula that I just now conveyed to you for the covariance. बात वही है जो मैंने पहले भी आपसे कही थी कि ये covariance है, the extent to which two variables vary together. तो जब हम खाली x की बात कर रहे थे उस वक्त लामुहाला हमारे पास कोई ऑप्शन नहीं था सवाए इसके कि हम x के साथ x ही मल्टीप्लाई करते, और अगर हम खाली y की बात करें तो हमारे पास कोई ऑप्शन नहीं है सवाए इसके कि हम कहें कि वेरिएंस ऑफ y इज इक्वल टू एक्सपेक्टेड वैल्यू ऑफ y स्क्वायर माइनस एक्सपेक्टेड वैल्यू ऑफ y होल स्क्वायर. यहां पे चूंकि हम दो वेरिएबल्स के इकट्ठे वेरी करने को मेजर करने की कोशिश कर रहे हैं, इसलिए our formula is covariance of x and y is expected value of x y minus expected value of x into expected value of y. ये तो हुआ covariance. And what is the correlation? Students, if we divide the covariance by the standard deviation of x into the standard deviation of y, we obtain what is called the correlation of x and y. So, as you now see on the slide, the correlation coefficient is given by the covariance of xy over the standard deviation of x into the standard deviation of y. Students, correlation coefficient in the case of a bivariate probability distribution is not denoted by R as we had in the case of sample data. Rather, it is denoted by the Greek letter rho. नहीं, रोने धोने की बात नहीं हो रही. It is a Greek letter जिसको हम rho pronounce करते हैं, और अगर आप उसे स्पेल करना चाहें इंग्लिश में तो आप स्पेल करेंगे RHO. अब इसमें भी कोई परेशानी की बात नहीं है. शुरू दिन से तो हम देख रहे हैं कि for the sample statistic we generally use the English letter, and for the population parameter we use the Greek letters. For example, sample mean x bar, population mean mu, sample standard deviation S and population standard deviation sigma. तो इसी तरह से अगर आप सैंपल का कोरिलेशन निकालेंगे तो आप स्मॉल r से डिनोट करेंगे, और अगर पॉपुलेशन के लिए या प्रोबेबिलिटी डिस्ट्रीब्यूशन के लिए निकालेंगे then it is denoted by rho. All right, let us apply this to an example. Suppose that we have a discrete bivariate probability distribution in which x takes the values 0, 1, 2 and y takes the values 0, 1, 2 and 3. The probabilities are as you see on the slide, and what we are interested in is to find the correlation coefficient between the random variables x and y. In order to solve this question, students, we can compute first of all E of x and E of y? The reason being that in the formula of the correlation coefficient, we will have to divide the covariance by the standard deviation of x and the standard deviation of y, the product of the two. और standard deviation of x निकालने के लिए we will need to find first the expected value of x, जिसका square हम करते हैं जब हम variance of x या standard deviation of x का formula apply करते हैं. So, proceeding as before, expected value of x comes out to be 1.10, expected value of y comes out to be 1.65. Also, we find expected value of x square by the formula sigma xi square into g of xi, and the answer is 1.70. In a similar way, expected value of y square, which is sigma yj square into h of yj, comes out to be 3.45. Substituting these quantities in the formulae of variance of x and variance of y, we obtain variance of x is equal to 0.49, whereas the variance of y is equal to 0.7275. अभी मैंने आपके साथ जो फॉर्मूला डिस्कस किया उसमें मैं पुरानी बातों को रिपीट करते हुए आपको रिमाइंड कराना चाहती हूँ कि एक्सपेक्टेड वैल्यू ऑफ x रेज टू k इज इक्वल टू सिग्मा xi रेज टू k इंटू f ऑफ xi. यानी मैंने आपको ये बताया था कि xi की कोई भी पावर ले लें, उसका जो फॉर्मूला है उसमें भी xi की वही पावर हो जाएगी. तो बाइवेरिएट सिचुएशन में वही सिचुएशन है, सिर्फ इतनी बात है कि वो जो डिस्ट्रीब्यूशन ऑफ x है उसको हम f ऑफ x से डिनोट करने की बजाय g ऑफ x से डिनोट कर रहे हैं. लिहाजा हमारा फॉर्मूला बना एक्सपेक्टेड वैल्यू ऑफ x स्क्वायर इज इक्वल टू सिग्मा xi स्क्वायर into g of xi. All right, having found the variance of x and the variance of y, students, the next thing is to find the covariance of x and y. As you now see on the slide, according to the shortcut formula, the covariance of xy is equal to expected value of xy minus expected value of x into expected value of y. Now, expected value of xy is computed in exactly the same manner as we did in the example that we considered in the beginning of today's lecture, and applying that procedure, it comes out to be 1.90. Substituting the values of e of x and e of y, the covariance comes out to be 0.085. Now, the correlation coefficient is given by the covariance of xy over the square root of the variance of x into the variance of y, and substituting all the values, the correlation comes out to be 0.14. आइए इस आंसर को इंटरप्रेट करने की कोशिश करते हैं. आपको शायद याद हो कि लेक्चर नंबर 15 में मैंने आपसे कहा था that the correlation coefficient always lies between -1 and +1. If there is a positive correlation between x and y, then our correlation coefficient is somewhere between 0 and 1, and if there is a negative correlation, then our correlation coefficient lies between 0 and -1. Of course, if x and y are absolutely uncorrelated, then the correlation coefficient comes out to be exactly equal to 0. तो अब इस एग्जाम्पल में it has come out to be equal to 0.14. तो आपकी इंटरप्रिटेशन क्या होगी? साफ जाहिर है कि चूंकि ये पॉजिटिव आंसर है, इसलिए हम ये तो नहीं कहेंगे कि there is a negative correlation between these two random variables. ये तो साफ जाहिर हो गया कि अगर कोई correlation है तो वो पॉजिटिव या डायरेक्ट है. एज x इंक्रीजेस y ऑल्सो इंक्रीजेस. लेकिन दूसरा जो बहुत अहम नुक्ता है वो क्या है कि द क्लोजर माई आंसर इज टू 1, द स्ट्रॉन्गर इज द कोरिलेशन बिटवीन x एंड y. और इस केस में एक्चुअली it is not at all close to 1. I mean that if you compare the distance between 0 and 0.14, that is much less than the distance between 0.14 and 1. लिहाजा हमारा आंसर 0 के करीब है और 1 से दूर है, and hence our final interpretation is that there is a weak positive linear correlation between x and y. ये जो लफ्ज linear मैंने कहा, ये मैं आपको लेक्चर 15 में पहले भी इंडिकेट कर चुकी हूं कि ये जो कोरिलेशन हम निकाल रहे हैं, एक्चुअली इट इज अ मेजर ऑफ द स्ट्रेंथ ऑफ द रिलेशनशिप बिटवीन द टू वेरिएबल्स इन अ लिनियर मैनर. यानी अगर हम ग्राफ के ऊपर प्लॉट करें तो हम ये देख रहे होते हैं कि स्ट्रेट लाइन का जो पैटर्न है, हमारे जो एक्चुअल डेटा पॉइंट्स हैं, वो हाउ क्लोजली दे आर following that linear pattern. Let us now discuss the computation of the correlation coefficient in the case of a continuous bivariate probability distribution. As you see on the screen, suppose we have the joint probability density function x square plus xy over 3 such that x lies between 0 and 1 and y lies between 0 and 2, and suppose that we would like to find the variance of x, the variance of y, and the correlation of x and y. In order to solve this question, the first step is to find the marginal PDFs. G of x comes out to be 2x square plus 3 by 2 x, and h of y comes out to be 1 by 3 plus y over 6. Next, we find the expected value of x, which is the integral of x into g of x, integration being done with respect to x, and the answer is 13 over 18. Similarly, the expected value of y comes out to be 10 over 9. Now, in order to find the variance of x, we can either apply the direct formula or we apply the shortcut formula. For the sake of interest, let us apply the direct formula in this example, and if we do so, we have expected value of x minus e of x whole square equal to the integral of x minus e of x whole square multiplied by g of x, and the integration is being done with respect to x. Now, x minus e of x whole square is the same thing as x minus 13 over 18 whole square, and substituting this in the formula, we obtain the product of two expressions which we can solve, and applying the integration, the variance of x comes out to be 73 divided by 1620. Students, I would like to encourage you to compute the variance of x in this problem by both the shortcut formula and the direct formula, and see for yourself that you get exactly the same answer. You don't have to get confused by thinking that the direct formula is something that is out of your hands. Absolutely not. In fact, जब आप इसके ऊपर खुद वर्क करेंगे तो आप देखेंगे कि it is quite simple. Similarly, we can also find the variance of y, and as you now see on the screen, the variance of y is equal to the expected value of y minus e of y whole square, and that is the integral of y minus e of y whole square multiplied by h of y, the integration being done with respect to y, substituting 10 over 9 instead of e of y, we have to find the integral of y minus 10 over 9 whole square multiplied by 1 over 3 plus y over 6. So we multiply these parts and we get a number of terms upon which we apply this integral, and doing all the calculations, the final answer is 26 over 81. To find the covariance of x and y by the direct formula, we have to compute the expected value of x minus e of x into y minus e of y. In other words, we have to find the double integral of x minus 13 over 18 into y minus 10 over 9 into the joint PDF x square plus xy over 3, and applying the integral in the same manner as we discussed earlier, we find that the covariance of x and y comes out to be minus 1 over 162. जैसा कि मैंने आपसे पहले कहा था, the correlation coefficient is equal to the covariance divided by the standard deviation of x into the standard deviation of y. So, in this example, the correlation coefficient comes out to be minus 1 over 162 divided by the square root of the variance of x, which is 73 over 1620, into the variance of y, which is 26 over 81, and hence the final answer is minus 0.05. Students, आपने नोट किया कि इस एग्जाम्पल में our answer is very close to 0, minus 0.05. So, what is our interpretation? We can say that there is a very weak negative linear correlation between the random variables x and y. बल्कि हम ये कह सकते हैं कि there is almost no correlation between the two variables in this particular example. यहाँ पे एक बड़ा इंटरेस्टिंग पॉइंट और इम्पॉर्टेंट मैथमेटिकल पॉइंट मैं आपको कन्वे करना चाहती हूँ, और वो ये है that if x and y are statistically independent, then their correlation will definitely come out to be 0. But the reverse of this statement is not necessarily true. बहरहाल मैं आपको दोबारा encourage करूंगी कि आप correlation, covariance और double integral, double summation इन तमाम तर concepts पर जितनी ज़्यादा practice कर सकें करें, so that you feel at home and comfortable and confident with these ideas. We have completed the discussion of the basic concepts of univariate and bivariate probability distributions, both the discrete situation and the continuous situation. And students, after this we begin the discussion of some important univariate distributions that are encountered in practice. यानी आप खुश होंगे कि हम बाइवेरिएट के बाद दोबारा से यूनिवेरिएट की तरफ वापस आ रहे हैं. The distributions that I would like to discuss with you are the discrete uniform distribution, the binomial distribution, the hypergeometric distribution and the Poisson distribution. इसके अलावा in the continuous scenario, I would like to discuss with you the continuous uniform distribution, and last but not the least, in fact most importantly, the normal distribution. तो आइए इस नए segment का आगाज करते हैं. We begin with the discussion of the discrete uniform distribution, and I would like to explain it to you with the help of an example. suppose that we toss a fair die and let x denote the number of dots on the uppermost face. Since the die is fair, hence each of the x values from 1 to 6 is equally likely to occur, and hence the probability distribution of the random variable x is equal to 1, 2, 3, 4, 5 and 6, and for each one of these x values the probability is 1 over 6. The sum of the probabilities is 1 and none of the probabilities is negative, hence we are dealing with a proper discrete probability distribution. आपने देखा कि इस particular probability distribution में तमाम probabilities identical हैं. So, if we draw the line chart of this probability distribution, we have a uniform distribution as you now see on the screen. Since the height of each of the 6 lines is equal to 1 over 6, hence we get a horizontal impression, and that is why this is known as the discrete uniform distribution. आपको याद है ना कि किसी भी distribution के लिए after drawing the line chart we are interested in the center and the spread of the distribution. So, in this particular example, if I wish to find the mean of this distribution, students, what do you suggest? वही पुराना formula, sigma x into f of x. x column भी हमारे पास है, f of x यानी probabilities का column भी हमारे पास है, and we can find the mean very simply. लेकिन what I would like to convey to you is that you do not even need to go through this formula in order to find the mean of this particular distribution. The point to be understood is that this distribution is absolutely symmetric. अगर आप इसके दरमियान एक आईना खड़ा करें, you will find that the left hand side is the mirror image of the right hand side, and hence the mean of the distribution lies at the exact center of the distribution. So, as you now see on the slide, the mean of this particular distribution is equal to 3.5. Once again, you might say कि 3.5 dots तो नहीं हो सकते. Of course not. अगर आप die को toss करेंगे, तो either you will get 3 dots or 4 dots or 2 dots or 6 dots. 3.5 dots per toss on the average. इसका क्या मतलब है? That if you toss it many times, then in every 10 tosses you can expect to have a total of 35 dots. The next thing is the spread of this distribution, and of course we would like to compute the variance and the standard deviation of the distribution. इसके लिए तो जाहिर है कि हमें formula apply करना ही पड़ेगा, and I would like to encourage you students to find the variance, the standard deviation and the coefficient of variation of this particular distribution on your own. Let us now consider another example. The lottery conducted in various countries for purposes of money making provides a good example of the discrete uniform distribution. Suppose that in a particular lottery as many as 10,000 lottery tickets are issued, and the numbering of these tickets is from 0000 to 9999. Since each of these numbers is equally likely to occur, hence we have the following situation. We have a uniform distribution in which the x variable has 10,000 values starting from 0000 and going up to 9999, and because the number of values is 10,000, Therefore, the probability of any one of these lottery numbers is 1 over 10,000. Now, the line chart of this distribution is absolutely uniform because of the same reason that we have exactly the same probability for each lottery number. Because of the fact that the height of every line is equal, we can see that this is a perfect example of a discrete uniform distribution. Students, ये जो एग्जाम्पल मैंने अभी आपके सामने पेश किया, आप जानते हैं ना कि इसमें जो क्रूशल पॉइंट है वो ये है कि एवरी लॉटरी नंबर हैज इक्वल चांस. देखिए ना, लॉटरी का तो मतलब ही यही है कि जितने भी लोग वो टिकट खरीदें, everyone has identical chance of being selected for the prize. तो इस हवाले से और इससे पहले जो एग्जाम्पल मैंने प्रेजेंट किया ऑफ द थ्रोइंग ऑफ द डाई, आपने देखा कि हर वो सिचुएशन वेयर यू हैव various outcomes which are equally likely, and you can express those outcomes in numerical form as a random variable x which takes values 0, 1, 2, 3 or 1, 2, 3, 4, or even values like you had in this example 0, 0, 0, 0 up to 9999, you do get what is called a discrete uniform distribution. नोट करने की बात यह है कि वो जो x की मुख्तलिफ वैल्यूज है ना, दे आर इक्वी स्पेस्ड, क्योंकि अगर उनके दरमियान डिस्टेंस फर्क होगा तो कुछ आप एग्री करते हैं ना कि कुछ प्रॉब्लम आ जाएगी. जो सिमेट्री है आपके लाइन चार्ट की वो शायद डिस्टॉर्ट होगी. आई वुड लाइक टू encourage you to think about it and to work on this point on your own. All right, the next important, very important discrete probability distribution that I am going to discuss with you is the binomial distribution. Students, this distribution was discovered by James Bernoulli around the year 1700. यानी 3 सदियां गुजर चुकी हैं, and even today it is considered a very important discrete probability distribution, and there are many situations in real life which can be identified with the binomial distribution. Let me begin its discussion with the help of an example. Suppose that we toss a fair coin 5 times and we are interested in determining the probability distribution of the random variable x, where x represents the number of heads that we obtain. अब इस प्रॉब्लम में आप नोट करें कि number of heads is going to be a variable that will go from 0 to 5. अगर आप 5 दफा कॉइन को टॉस करें तो वेरियस पॉसिबिलिटीज क्या हैं? सबसे पहली यही है ना, that you do not obtain even a single head, or you can have 1 head or 2 heads, 3, 4, or you can have 5 heads. जाहिर है कि अगर आप कॉइन को 5 दफा टॉस कर रहे हैं तो 6 हेड तो नहीं आ सकते ना. Hence, we note that in this kind of a situation, our random variable x goes from 0 to 5, generally speaking, from 0 to n, small n, where n denotes the number of trials. ये जो term मैंने अभी इस्तेमाल की, this is the technical term that we have for the binomial experiment. Formally speaking, a binomial experiment is that experiment which satisfies the following 4 conditions. Number 1, every trial results in either a success or a failure. Number 2, every trial is independent of every other trial. Number 3, the probability of success remains constant from trial to trial. And number 4, the total number of trials, that is n, is fixed in advance. Students, ये जो 4 प्रॉपर्टीज मैंने आपको कन्वे की हैं, these are essential for us to be able to apply the formula of the binomial distribution. इसलिए पेशतर इसके कि मैं फॉर्मूले की बात करूं, I would like to discuss with you these points in detail one by one. सबसे पहले हमने कहा कि every trial results in a success or a failure. देखिए, सक्सेस और फेलियर यहाँ पर टेक्निकल टर्म्स हैं. सक्सेस का ये मतलब नहीं है कि हम उस चीज की बात कर रहे हैं जो कि बहुत अच्छी बात है, और फेलियर का मतलब हो कि हम उस चीज की बात कर रहे हैं जो कि गलत बात है या बुरी बात है या कोई फेलियर है. इट इज अ टेक्निकल टर्म एंड इट सिंपली मीन्स दैट द outcome that we are interested in is called success, and the outcome that is the complement of what we want, that is called failure. For example, suppose our experiment is that we are testing any person for any particular rare disease. जब आप उसके ऊपर वो टेस्ट कंडक्ट करेंगे, उसका रिजल्ट या नेगेटिव आएगा और या पॉजिटिव आएगा. नेगेटिव रिजल्ट का मतलब है दैट दिस पर्सन डज नॉट हैव दिस डिजीज, और पॉजिटिव रिजल्ट का मतलब है कि ही डज हैव दैट डिजीज. अगर हमारा इंटरेस्ट उस डिजीज के बारे में रिसर्च करने में है, तो फिर स्टूडेंट्स द प्रेवलेंस ऑफ द डिजीज विल बी रिगार्डेड एज सक्सेस. सो आउट ऑफ अ सैंपल ऑफ 10 पेशेंट्स, if 3 of them do have the disease and 7 of them don't, then we are saying that there are 3 successes and 7 failures in this particular example. ये तो था पहला point. And the second point was that every trial is independent of every other trial. इस example में हम इसको यूं समझेंगे कि वो 10 अफराद जिनको हमने टेस्ट किया, they are independent. यानी आप इसमें बहन भाई नहीं हैं. अगर बहन भाई होते तो हम कहते कि जेनेटिक, कोई जेनेटिक लिंक है उनमें और समथिंग लाइक दैट. हम कहते हैं दैट द ट्रायल्स आर इंडिपेंडेंट. एंड द थर्ड प्रॉपर्टी इज दैट द प्रोबेबिलिटी ऑफ सक्सेस, जिसे हम स्मॉल p से डिनोट करेंगे, दिस प्रोबेबिलिटी शुड रिमेन कांस्टेंट फ्रॉम ट्रायल टू ट्रायल. अब इस एग्जाम्पल में हाउ डू वी डिसाइड दैट दिस इज हैपनिंग? देखिए, इस प्रॉब्लम में हमें रिलेटिव फ्रीक्वेंसी डेफिनेशन ऑफ प्रोबेबिलिटी अप्लाई करना होगी. और वो जो लार्ज पॉपुलेशन है ना, जिसमें से हमने ये 10 अफराद लिए थे, उस पॉपुलेशन के अंदर जो प्रोपोर्शन है उन लोगों का कि जिनको ये डिजीज है, दैट प्रोपोर्शन विल एक्ट एज द प्रोबेबिलिटी ऑफ this particular disease. So, for example, if in the large population we have this knowledge from past records that 5% of the people have this particular disease, then we say that the probability of success is 0.05, and this probability remains constant from trial to trial. यानी वो जो 10 अफराद हमने चुने, उनमें से हर एक के लिए ये probability बराबर समझी जाएगी. The reason being that they are independent and they have come from that same population. The last point is that the number of trials is fixed in advance. इस प्रॉब्लम में हमने पहले से तय कर लिया था कि हम 10 अफराद को टेस्ट करेंगे, and so the number of trials is 10. Students, in the next lecture, I will discuss with you the binomial distribution in more detail, and we will be looking at the formula of the probabilities that will be computed in any such situation where these 4 properties are fulfilled. In the meantime, you will be practicing the concepts of covariance, correlation, and the discrete uniform distribution. Best of luck, and until next time, Allah Hafiz.